Welcome to the panel on leveraging NOMS technology to maximize benefit. My fellow session co-chairs are Greg Maxwell of CMT Engineering and Jerry Gerspatch, he's in the back there, Port of Oakland, and contributor Justin Cook. Our first speaker is Greg Maxwell. As a principal aviation noise consultant for CMT, Greg oversees all noise management studies. He's an industry recognized expert in aviation noise abatement and flight performance analysis who works with airports, airlines, aircraft manufacturers, the community, elected representatives, and the FAA to address aviation noise concerns and advance aviation in an environmentally sustainable manner. Welcome, Greg.
Thank you. So today I'm going to talk to you about Philadelphia, or a portion of Philadelphia's noise flight quiet program. Our focus there, CMT manages the noise office for the airport, and our focus in our flight quiet program has been looking at mostly flight procedures. And so this is kind of I'm going to walk you through the analysis that we did to look at the departure analysis for nighttime. First off, I just want to start with what is the NOMS. So in its basic form, you have your data inputs, which is most of your flight data, your noise events and complaints. There's some other components, but we'll just kind of focus on these. And then those all get input to a server, and you have your data correlations that the system does. And then it produces outputs in the system, which is either visual or reports or whatever. So that's kind of what we're talking about when we're talking about a NOM system. And this is not to say that every NOM system looks like that. They're all highly customized to the individual airport's needs, but generally this is what a NOM system does. So in our analysis, the goals that we established, first off, I think it's critical that you understand the operational environment, what you're dealing with. Because if you don't have a good understanding of that, then you're going to have a hard time when it comes to, quantifying and having success measures, because your goals that you may be trying to achieve may be unrealistic based on the constraints of the system that you're operating in. Then you want to monitor flight operations, quantify flight performance, report success metrics, identify opportunities to improvement. That's key, I think, because you're in any flight quiet program, your measures should not be static, right? You should always be evolving, reevaluating, and reassessing, are we keeping up with changes to the airspace and, things that are happening at the airport. And then you need to hold all the stakeholders accountable. That includes the airport, that includes the FAA, that includes operators, and then review your progress and recalibrate. So we do that on an annual basis. We look at these measures and say, does this still make sense? What do we need to do? So here's just a little profile of Philadelphia for 2022. We're 21.8 million passengers and about 284,000 operations. And there were 110 nonstop destinations, 26 of those being international, and approximately 6.2 million people live in the 11 county Philadelphia MSA. Philadelphia Airport, its configuration, there's 4 runways, 7 terminals, 126 gates. That blue dash line that you see is actually the county line. So the airport actually straddles 2 different counties, which creates some interesting challenges when you talk about master planning and where you're going to locate different facilities. Because when you start moving things around, one county gets upset because they lose tax revenue. So it's an interesting situation to deal with. And then you have the fact that you have basically 3 different states that are influencing decision making at the airport. There's 2 different configurations that the airport operates in. East flow, which is about 30% of the time. And as you can see, runway 8 is not available for arrivals. That's because that approach would take them right over the top of the terminal. And there's also a fuel farm just to the south there. just to the north of runway 9 left, 27 right. So can't land on that runway. And then the opposite is true in west flow, which is about 70 to 75% of the time Philadelphia operates in west flow. And there are no departures allowed from runway 26 for the exact same reason, because there is no runway overrun, and you would end up basically either in the fuel farm or in the terminal, neither of which would be good. So the primary runways for arrivals and departures are 27 left and right, and 9 left and right. And runway 1735 is used, but is not independent. It can't be used independently. So when that runway is in operations, air traffic control has to produce or leave a gap in there for traffic, so it doesn't add a tremendous amount of efficiency. So Philadelphia has one standard instrument departure, and this is it. It's basically a radar vector SID. So we have different waypoints based on where aircraft are flying to. And so you get assigned one of these waypoints on departure, and air traffic control says, fly this heading, and then they turn you on course to that waypoint, and that's it. And there's a lot of reasons for that, but one of those is because we're basically, constrained by both New York and Washington. We're basically right in the middle. The dividing line between New York and Washington airspace is pretty much right over the top of Philadelphia. So it creates some interesting challenges when you look at operationally what can be done. So in east flow, nighttime departure, if you're departing runway 8, you fly runway heading. It's basically only RJs. And then runway 9 left and right is a runway heading to 110 degrees. And we'll see why that's somewhat problematic from a noise abatement standpoint and a little bit later. And basically you have to fly that heading until you reach 6 DME or 2,000 feet. In the FAA SOP, it's defined as AGL, but actually it should be MSL. And that measurement point is from the approach end of runway 27 right. So that's where the 6 DME is measured from. West flow, it's a 245 degree heading straight off the runway. And that's a single heading that's used. And it's, instead of being 2,000 feet, it's 3,000 feet, same 6 DME. So it's an either or, either you get to 6 DME or you get to 3,000 feet, and then you can be turned on course. So when we looked at how we should measure this and analyze performance, there were a couple of things that we needed to consider. So one is limitations of the instrumentation. So when you're getting data out of your NOMS system, then you're getting altitude readings, and you have a hard cutoff, let's say at, in this case, 2,000 feet for eastbound. Well, the average altimeter does not have an accuracy. It's plus or minus 50 feet. So anything less than that, and it may be tagged as a violation when in fact it may not be. You also have to consider how fast those airplanes are flying. So in this case, if they're at 2,000 foot per minute climb rate, that's about 250 feet every 7.5 seconds. And then if you look at how far they're traveling, laterally in that time, so you can get a sense that, you may be operating on the margins when you're talking about, well, this flight deviated, and it was 100 feet below that altitude cutoff. Well, how much time are we really talking about, and how much distance is that? Because the instructions that they're receiving from air traffic control, and how they're trying to sequence those aircraft and get them out of the departure corridor and do those handoffs, that all has to be considered. So you have to allow for some margin, some error, right in there. Otherwise, it's not really realistic. Then you also have to consider individual airline SOPs. So each airline kind of has may have a different SOP as far as when they allow that turn to happen. So, you're gonna climb on runway heading to a certain point, and your acceleration height, although you may be following a standard, NADP profile, usually 2, That acceleration height might not be 800 feet always. It might be 1,000 feet or 1,500 feet based on individual airlines. So you have all these kind of considerations that you have to think about. So when we look at west flow performance, this is what we came up with our altitude ceiling. So we gave a buffer of about 250 feet. And what we were trying to protect for most was overflights over the north shoreline of the Delaware River, and then premature turns to the south. So as you can see, most of those aircraft performed pretty well when we look at 2022 and maintained that 245-degree heading. There were some deviations, but the other thing you have to consider is you need to make an effort to remove deviations for things like weather or traffic spacing, or establish criteria that eliminate those from consideration. Because if you go to air traffic control and say, well, you had these deviations, and then they go and they investigate them and find out that half of them were for weather, it's not gonna be a conversation that's gonna go well, because their time is limited, and you really need to do the best that you can to limit the amount of information that you're providing them so that they can focus on those deviations that are key that can't be explained by other factors. The difference in east flow is pretty remarkable. As you can see, the track spread, they're not really flying 110-degree heading. They're kind of all over the place. And we'll kind of look at that in the next slide, and you'll kind of see why that is. But we were given the same 250-foot buffer. So we look at west flow, less than 1% of the 8,000 total east flow nighttime departures, we're not in compliance. So not a problem here. We're really happy. We're obviously, there's some changes that we can make and some conversations that can be had, but for the most part, it's pretty good performance. And you can see how this breaks out based on destination. So whether they're westbound, transatlantic, and southbound, based on the destination. However, when we look at east flow performance, it's a whole different matter. So 43% of the 3,286 total east flow nighttime departures did not fly the 110 noise abatement heading. So the question becomes, well, why? Why didn't they do that? Well, what's interesting is, even though there was 43% of the flights that didn't fly that departure, you can see that that number that actually recorded a violation is much smaller. So the only reason that they didn't record a violation is because they were over the altitude ceiling. So they hit that 2,000-foot mark, and so that they weren't recorded as a deviation. But you can see that the most of them were westbound departures. So what's happening there is that 110-degree heading is not really efficient from a departure standpoint of you're having to fly a lot more track miles if you're going to the west. And so they're just basically allowing them to fly straight out runway heading. So when we kind of look at the analytics for east flow, and one of the things that jumps out right away is, well, if you look at the distribution of nighttime departures, UPS by far has the most number of operations, which makes sense because they have a large cargo hub at Philadelphia. And so they have 35 non-conforming departures, and you say, okay, well, that's not really the whole story, though. If you look at the number of operations they have during 2022, and then you look at the percentage of non-conforming departures, that's only 2%. So it's important to not just look at how many, deviations did you have, but there has to be some context behind that. And then this gives you a breakdown of the altitude based on the aircraft category by regional jet, narrow body, and wide body, and then the individual aircraft type. So with this information, we identified opportunities for improvement. So one of the things right out of the gate, me kind of putting my flight performance hat on, I went and I looked at what is actually charted on the procedure. So on the Jeppesen chart, well, there you can see in the bottom right-hand corner, there's a mention of the 245-degree noise abatement heading, but there's nothing about east flow. So the pilots have no idea that procedure even exists. So how are they supposed to comply with it when there's nothing even charted on the Jeppesen chart? So our thought is, well, we need to resolve this discrepancy between what the FAA SOP says and what's charted on the PHL SID. Then we looked even further and we said, okay, well, here's the FAA's SOP, and it says that they're going to fly runway heading to 110 degrees, departures off of 9 left and right. Well, they're not doing that. So the question is, why is that not happening? And what can we do to try to resolve that? So what we decided is that we need to develop a nighttime noise abatement kind of education for the controllers. And then we need to set a target for improvement that everybody can agree on. So, it's kind of two-part. We need to understand why they're not using that heading. And then does it make sense that maybe that heading should be modified because it doesn't meet the requirement or the what's established in the noise compatibility program, the approved Part 150 noise abatement procedure is different. So they changed from the approved procedure and implemented this SOP, which they're not following. So our idea is, well, what if we fly 100 degree heading? Because that would really be more in the spirit of the original noise compatibility program approved measure for that departure, which would keep aircraft over the Delaware River before they made that turn and wouldn't send them out over New Jersey over those residents, which doesn't really make a lot of sense from a noise abatement standpoint. And it just seems to be kind of a random heading that they've chosen. So that's kind of what we have proposed. And so we're in the process now of having those discussions with them and trying to resolve that and get some improvement.
Thank you, Greg. Our next speakers are Marie-Jo Fremont and Phil Stollery. The speakers are going to combine their times and they're going to present and engage in a dialogue together on NOMS. Marie-Jo is the co-founder of Concerned Residents of Palo Alto. She's trained as a scientist and holds an MBA from UC Davis. Marie-Jo also brings 30 plus years of experience in R&D and operations at Fortune 500 high-tech companies. Since NextGen started in March 2015 in the San Francisco Bay Area, she's been advocating for aircraft noise reduction locally as well as nationally. Phil currently oversees a global team providing services that complement Envirosuite's noise and operations, monitoring and community engagement technology. He's been involved in aviation noise and environmental management for over 30 years, initially designing airport noise monitoring terminals and then on to software development, business development, and as head of product marketing, responsible for Envirosuite's product strategy. Please welcome Marie-Jo and Phil.
So thank you, Darlene. And so we're going to try something new and we don't know how it's going to work, but you have to try it. So today we're going to try to take you from data to actions. And we are going to, we're going to cover 4 topics. First, how important NOMS systems are, how valuable they are. We're going to talk about quantifying noise impacts and how to report content that is relevant, informative, and actionable. And we'll end with some recommendations. So communities are very simple questions. Why am I impacted? By how much? And what can we do about it? And the good news is that NOMS systems can help answer some of these questions because NOMS can provide the data and from which information can be extracted, and then it can be used to take some action. So question for you, Phil, is how important, how valuable are NOMS systems in particular to airports, and how do airports use them today?
So I'll talk a little bit first about the value of NOMS, and then we'll go on to talk about what they're used for. And I kind of distilled it down to 2 things. Firstly, a NOMS is valuable because it helps an airport understand what's happening as opposed to what they expected to happen or was planned to happen. And for the community, the same data coming out of a NOMS is useful to help them understand what's happening as opposed to what they think is happening. And it's hugely important to get both of those elements clear because it then allows both the airport and the community to have a fact-based conversation. And that fact-based conversation is important because dialogue without facts really has the potential to diminish understanding and destroy trust. And that is a source of annoyance in its own right. Or the opposite of what the airport's trying to do with a dialogue with the community in the first place. So in addition, a NOMS is used to help the airport do root cause analysis and trend and historical analysis to develop an understanding and mitigation strategies. Greg just gave a very good example of exactly that and how NOMS was used to do that in the case of Philadelphia. And then those insights in turn can be shared with the community themselves so that they can understand those impacts, understand the causes, and that helps build an understanding of what's going on and set expectations. Again, another important of that. In terms of how NOMS systems are used, I've split it up into sort of three areas. We've got airports that have no NOMS system. We've got airports that use a NOMS purely for statutory reporting. And then there's a set of airports that have real community issues to address. And they tend to have or use NOMS in a more sophisticated way and in a more detailed way with lots of data. I'm going to show a slide here, which I've actually shown at this conference before a few years ago, but it's still very relevant. That no NOMS segment, if you like, we can call that the first generation. And that's where an airport either doesn't have a noise problem or doesn't believe it's got a noise problem, doesn't want to take any action on that, and therefore has not invested in a NOMS system to do that. Moving rapidly to generation 2, they'll introduce forms of measurement. So that might be noise measurement. It might just be related to measuring operations and where flights are flying, etc. But at least it's the first step for an airport being able to measure and then understand and report what's happening, and then use that information in working with communities and challenging and defending situations. When we get on to looking at airports that have real community issues to address, we move to generation 3. And that's really the first time we start to use the systems to help reduce environmental impact through this phase of abatement. And that's where we start to use modeling and forecasting and compliance. Again, you saw that in Greg's presentation. Might be budgets and penalties applied on there, and some degree of airline engagement to help drive best practice in the way airlines are flying procedures in and out of the airport. And then finally, we've got the 4th generation, which we termed partnership. And this is largely around trying to help the airport maintain its social license to operate. And that's done through education and communication, cooperative planning. We saw that in the previous session through roundtables, complaint resolution, information sharing, and agreed KPIs. So there are a few airports still in that 1st generation. There's lots and lots of airports in that 2nd generation. And there's also many airports in generation 3 and with elements of generation 4. And you'll have seen that throughout the day today. And NOMS underpins really, obviously, anything from generation 2 onwards. So essentially, NOMS helps airports quantify aircraft noise impact in the surrounding communities. And they do this with that combination of modeling and forecast measurements. So let's have a closer look at both of these.
Sorry, you can either model noise or measure it. So in terms of modeling, what you're doing is you're predicting noise at any location you want. You can just pick a pin, as Pioneer said, anywhere. And that's sometimes referred to as virtual monitoring. Airports consultant, the FAA does this. But like any model, a noise model has limitations. So in case of the ADT, it's pretty good close to the airport, except for the ground-based noise at the airport. And it's not so good beyond a few miles far away from the airport. And again, like any model, the precision and accuracy will be based on the model complexity, the parameters you're using, and the assumptions you're making. And in terms of the data processing, it's semi-automated in the sense that you still have to input some data and select some parameters. In contrast, if you measure noise, you are putting a noise monitor at a specific location. So you cannot do it everywhere. And airports or cities monitor noise typically close to the airports. They deploy and they maintain this equipment, so it's not as flexible. And then you have to do some good data processing behind to identify the aircraft noise events. And that will depend on the methodology you use. So I have 2 questions for you, Phil. First, can you comment on modeling, versus measuring? And especially for communities that are 5 miles away from the airport, is it reasonable to use noise modeling results to make conclusions or decisions?
Okay, good questions. I think firstly, to take the first one, it's important to understand that both modeling and measuring have got challenges. Both of them have got problems. With models, typically the models are based on specific aircraft configurations, maybe standard altitude profiles, and the appropriateness of those configurations and profiles to the airport that you're modeling with may be good, may be less appropriate. Second point is that the contours really give an illusion of accuracy and discontinuity. And by that, I mean, depending on how the contours are presented, it can give the impression that there is an exact value around that, rather than, as we've seen in previous session, there's a range of uncertainty, if you like, around that. And that discontinuity is important because the lines there can suggest that one side of the line there's a lot of noise, and the other side of the line there's no noise at all, and that's hugely misleading. So sometimes it may not relate well to the community response. And overall, I think it's a generally accepted point for communities that the methodology in modeling is opaque and therefore less trusted. Measurements. However, the challenges with measurements are a little bit different. When we take a measurement, we actually measure everything, not just aircraft noise. So every measurement is a combination of aircraft noise and some amount of community noise. And depending on where you're measuring and what's happening in the community, that can cause problems and errors in measurement. Best practice requires a significant deviation above background noise levels, typically 10 decibels or more. And that can be very challenging when you're looking to measure in communities, particularly further away from airports where aircraft noises are lower and into communities where community noise is higher. And to your point, Mary Jo, I'd love for airports to have thousands and thousands of noise monitors, but because they haven't, it provides a limited geographical coverage. So I think your second question was around, is it appropriate to use noise models more than 5 miles out from an airport? And clearly that becomes more challenging. We saw in the previous session that the uncertainty of models or the margin of error increases the further out that you are. But that's not to say that they're not useful. They can still be used to show trends, changes in time, for example. So whereas the absolute level might not be precise, then you can still use the trend information. But also, I think it's important to understand that models don't cover every aspect of what a community wants to see. So things like non-standard operating configurations or procedures or ground noise and other aspects like that are not part of those noise models, and so they won't reflect the response that we see from that. So with respect to measurements, let's dig into the techniques used to separate aircraft noise from everything else.
Here's how you're going to separate aircraft noise. You're measuring noise, so you're recording everything, and you need to separate your aircraft noise from anything else, which is, other traffic noise, construction, etc., leaf blowers, whatever. So there are two methods that can be used. The famous threshold and duration method, which has been widely used for decades, and the more recent method called ANIM. And so I would like for you, Phil, for the audience to contrast the two methods and tell us if one is better than the other and if airports can use either method.
Thank you. So I've got some examples to show here. But on the left-hand side here, you see what we call either classic event detection or standard event detection. We're looking for a deviation above a detection threshold for a certain amount of time. And those thresholds are then used to identify those, take that measurement, and then assign it to the nearest flight that was operating within a zone of influence around a noise monitoring terminal. I've got 3 examples here just to show you some of the challenges with that. We'll start with where that works well. There's nothing like aircraft noise at an aircraft noise conference to get everyone excited.
Thank you.
So that clearly works well in that situation. You've got a very clear aircraft noise and it exceeds the threshold of 70 decibels for a significant period of time. In the second example is where it doesn't work so well. And because the aircraft noise is quieter, it hasn't exceeded the threshold for enough time. And so therefore systems tend to miss that and assume effectively the reporting says there was no aircraft. The third example. Now, clearly there, you've had an exceedance for the required amount of time. So classic event detection will capture a noise event and then assign it to an aircraft. And clearly a large amount of noise energy there is not related to the aircraft. So we get an incorrect measurement. So we see our reporting then says, or the NOMS reporting then says, well, we did have a measurement, but reports it too high. So we have a novel aircraft noise event detection methodology, which we call a NEM, and it works slightly differently. First of all, it starts with the flight, and it looks at every flight that passes within a certain area of influence around a noise monitoring terminal. It looks at the time that it enters that influence, and then it goes to search the noise time history. And the advantage of doing it that way around is it means it can then look for exactly what was happening acoustically just before that aircraft entered that space. That we can then measure as the background level, and we then look for a deviation above that background level. That means we don't have that second situation where we've got noise thresholds set too high and we miss things. So we generally capture more events. To avoid the second example, or the third example that I showed you in the previous slide, we then go into this phase 3 where we look at the measurement that we've got and we check to see whether it is commensurate with what we would expect that aircraft to make that distance away from the noise monitoring terminal operating that particular procedure. So it's a check that we are actually taking a valid measurement. And if it isn't valid, we reject it as such. So we avoid that. So that's that dual benefit of making sure we capture more aircraft noise events and making sure that the ones that we do capture are actually measured correctly. And I think just to refer back to that maturity chart I showed a couple of slides ago, as you move further up those generations to generations 3 and 4, the importance of getting an accurate assessment of aircraft noise becomes much more important. You're trying to set expectations, you're sharing data, you're building trust, you've got to make sure you're doing it right. And that's why it's important. And just to finish on this section, here's an example. A NEM is being used in airports across North America and Europe. Here's an example from a European airport that applied a NEM, and we increased detection levels from 2% up to 90-odd% in time. It's not perfect. It's not claiming to get 100%, but 96 is pretty better than 2%. So I think to answer your question, either method is acceptable according to international standards, and they're both comply with the international standards. And clearly in many cases, particularly when you're monitoring further away from an airport, something like a NEM can help address some of the problems we've shown. So having obtained good information, let's look at about how the NOMS data itself is used.
So the good news is airports who have NOMS systems have data, and many airports publicly report their data, and that's great. And some airports really invest considerable resources in their reporting. The bad news is, on the other hand, the reports are typically a high level and for a broad area around the airport, and they're usually snapshot. Sometimes they report trends, but not always. And again, it's for all the operations, doesn't necessarily break down, arrival versus departures or cargo versus commercial. And they also typically report plenty of tables and charts, and that's great. Some people are very good at reading that, but not everyone. And so they don't go the next step, which is to offer few or no insights. And so my questions to you, Phil, is what do airports typically report today? And can you touch upon data versus information?
Absolutely. So here's a couple of examples of what I would call data as opposed to information. These are typical statutory reporting from airports. They convey data. There's some information, but there's not a huge amount here. On the left, there's some information about what is flying where and when. And on the right, there's some information about how many flights there were relative to the last year. But both reports are very broad, right? If you're not under the departure path on the left-hand side, then there's not much information here for you. And similarly, on the right-hand side, understanding where an aircraft has come from or where it's flying to isn't going to tell you much about how much noise impact it's given you. To contrast that, here's a couple of examples of what I call information. And we're taken, in these examples, they take exactly the same sort of data you get out of a NOMS system, but present it very differently. So here on the left, we've got information that is presented to directly answer the sort of questions that communities are asking. It's targeted on a particular location of the community member, so you don't have to try and interpret whether you're under the 19 left departure. You give it your postcode or your zip code, and it will then work out the stats relative to you, and that helps to build your understanding of what's happening around you. So how many aircraft are flying near me? How frequent are flights in my area? These are direct answers, or using metrics from a NOMS system to directly answer those sorts of questions. On the right-hand side, we've got an example at the top there, which is a look back at history of what was happening the previous 2 weeks. And this is very helpful for someone looking at this data on a website, because they can see what was happening in the last 2 weeks. And then underneath it, they've got a prediction or a forecast or a look ahead, as it says there, of what's going to happen in the next 2 weeks. And that helps them understand, well, sets my expectations based on what I experienced in the last couple of weeks, which is top of mind. So Marie-Jo, do you think that's the sort of information that communities are looking for?
Thank you for that question. So I'm going to summarize what communities are looking for in terms of information. So first, they want context and trends. You know, that's the background that sets the stage, what's happening at the high level, if you want. But they also, and very importantly, they want to understand what's happening to their specific community, what impacts, what are their impacts there. And then they want to get to root causes. The ultimate goal is to take actions and based on facts, because the first 3 steps of providing information is to establish facts that enable the conversations among the stakeholders to then to get to taking some actions. So let me try to explain what I mean by all of these context trends, etc. So context and trends are data that are high level. So number of operation growth rates, operations mix, cargo, commercial, etc. Which procedures are used, what your DNL contours until we get N above contours, noise complaints, etc. And in terms of information, people want to know what are the trends and what's changing. Is it getting better or worse? So here's an example of a general airport in Colorado that does report, for instance, their monthly operations and their complaints. So the blue line is the operation, the red line is the monthly complaints, and they show this trend. However, when I look at this chart, okay, well, there's no insights, but I'm not too stupid. So I'm thinking, yeah, it correlates pretty well. There are more, more operations, more complaints, but there's no so what. It doesn't help me much. So I couldn't find a good example. So I created one of what I think would be better. And this is based on SFO data that are published in a couple of different reports over many months. And these represent the quarterly SFO operations in blue, and against the quarterly complaints received by SFO in red. And I did it for 5 quarters. And I wrote on the right side some insights. So these are my words. Well, the volume of operations obviously didn't grow. It was steady across these 5 quarters. But everyone can see that the volume of complaints started to increase tremendously starting in Q2. 2015. And I know that there are a couple of things that happened at that time because I live there or under the flights. Next Gen was started to be implemented in Q2 2015. And then there was also at the end of 2015, there was a new tool to report complaints called subject noise. So these are kind of things that I think community would like to have. So my question to you, Phil, can airports capture, insights, not just reports and the tables and charts, and can they add their own knowledge?
Oh, absolutely they can, and they do. We've seen some of that in the presentations today. But the important key thing is that the information that is presented is relevant to the community. And we need to understand the community is not one community either. It's a collection of different communities who are impacted by different things that need reporting in different ways using different metrics and different visualizations. So it's imperative in order to get to that point that there's a clear dialogue between the airport and the affected communities to be able to work through those issues so that the airport can use the NOMS to provide the information that's appropriate to address what it needs to address.
So talking about community-specific impacts, which is really the most important thing, is community want to know what's happening in their communities. So this is back to what was mentioned by previous speakers, where you do some grid reporting. You pick a particular cell if you want a particular location, and then you report for that community, and you analyze the data over time. And the kind of data that people want to see is multiple noise metrics, definitely and above. And they also want to understand which procedures are used, and meaning by this, what are the actual characteristics of these procedures, and how do they comply compared to what they're supposed to do in terms of, ground track, altitude, speed. And then they would like to know also what are the loudest flights and also the quietest flights. These are really the kind of data that people want to see. And again, extracting the information from that is, what do you see? Are there patterns there? And are things getting better or worse? So let me show you an example of the UK community impacted by Heathrow airport. And you can see the reporting and above data. So there's a chart that shows based on 6 months data, they averaged everything, and they're reporting 3 values of and above 60 dB, 65 dB, and 70 dB in different colors. And they display this on a 24-hour basis based on that average. And they also write on the left of the chart quite a few comments, which makes it really more understandable for communities to understand what do you look at this chart. What's missing is, I don't know from this, is it getting better or worse? I have no idea. This is a snapshot. However, my question to you, Phil, is how difficult is it for airports to report this kind of community-specific impacts?
So I think depending on the NOMS, it can be straightforward. Most NOMS have got all of the data necessary to mention some of the things that you've highlighted there. I think the greatest challenge for the airport is really the effort required to provide the data to a large number of different communities experiencing different things, to the point I made earlier. Clearly, technology can help, but the challenge is that issues change and they develop, and we can develop technology to present very simply metrics like this, but the FAA can come out with a paper and consult on that and come back with different metrics, and then everything has to move on. So it is a challenge that things move, and it can very quickly become a burden to try and address all of that.
Thank you. So last but not least, what communities really want to get to is, why is this happening? So tell me, the root cause. So communities want for these specific problems to be investigated. And that means there is no one-size-fits-all report, because it will be specific to the problem at hand. And it may be an iterative process, because you may uncover some information along the way. So here's a good example of a root cause analysis on early turns in San Diego for departures. And this report shows the trends, and you have, different years reported, but it also shows in the middle to the right, the causes of the early turn. And they have 3 categories. Is it vectoring by air traffic control? Is it the pilot deviating from the procedure, or is it caused by weather? And then you don't see this here on this particular slide, but it is in the report. It also lists the number of early turns by airlines. So when you take this report, you can really take some actions, which is next step. Let's go talk to air traffic control and try to understand why they're vectoring so much, and talk to the airlines. Why is it that's happening more with this airline versus another airlines? So all of this is done with NOMS, and so it's doable, right? So
yeah, that's correct. All of that data will come out of NOMS systems, and this is an example of a very well designed report. It deals with a specific issue. And it tells a story of how well that issue is being addressed over time. And I don't know in this case whether it was done collaboratively with the community, but clearly there's some dialogue there that said, well, this is how we're going to get the point across as to what's happening and how well we're doing. So it really, hopefully it allows people to see action and hopefully correlate that with a benefit that they experience in reality.
So let me summarize. Sorry. the community's needs for information. So in terms of context and trends, as well as community-specific impacts, there's some major things that communities want to get. Quarterly reports are good enough. Things don't change that quickly. Monthly is an overkill. They really want to see trends because changes are important. And they want content that is relevant to their community. So going to grid reporting is important. Every community is different, impacted differently. And breaking down the nighttime versus the daytime is also important because the impacts are different and the level of traffic is very different. And they want data and information on the procedures that are used and how they're impacted by these specific procedures. And also they need the insights. Tell me what you are seeing from this data. In terms of root causes, what they want is a custom report and analysis on the specific problem. So can airports meet these community needs?
So yes, but there's always a but, right?
But.
Airport noise teams need that constructive, collaborative community relationship. They need to know the specific issues that are causing impacts, and they need to agree with priorities with the communities and a management approach on those. That last bullet point is also important, right? There needs to be an acceptance that not all noise issues can be addressed. And it's important to note that many airports don't achieve best practice outcomes for their communities, not because they have the wrong technology, but because they're unable to effectively manage the operational issues, by which I mean they're limited really in what they as an individual organization can achieve within a complex system like commercial aviation. It's not just about the airport and the community. We've got airlines, we've got regulators, we've got air traffic controls, all with potentially competing priorities. But then the community, as I've said, is not just one community. There may be conflicting priorities between the community themselves. And you've got politics on top of that. That's come up in the previous session as well. And we shouldn't forget interdependencies with other environmental improvements around carbon reduction and local air quality. And then when you add on the other constraints around the airport, around social connectivity, economic activity and jobs, etc., you can see it's a hugely complex situation. And to talk about just optimizing for noise without any consideration of the benefits or any of the other constraints around there, it's not right to look at it in that way. So it's not just a matter of flying differently. There's a large amount of competing issues which has to be balanced. And again, that balance term came up earlier on this morning, and it's a very important aspect to cover.
So let me end with some questions for the communities. You cannot reduce noise, or if you don't have any information on the impacts and what's causing them. So the question that communities should ask themselves is the content you're getting today from the airport, is it relevant to your community? Number one. Number two, is it informative? Meaning by that, is it understandable? And are you getting the data that are appropriate, that are needed? And are you also getting the insight? And then third, is it actionable? Because the goal is to do something with them, with this information. If the answers are no, then you need to sit down with your airport and discuss at least 3 topics that I've listed here. How do they quantify the impacts today? How useful and actionable are the current reports? And also, can the data be accessed? Because airports cannot necessarily do everything, but there might be other members of the community or otherwise who could, if the data were provided, could do some analysis. So let me provide some specific guidelines on these 3 topics. In terms of impacts, if the airport is measuring noise, they should use an NEM whenever possible because it is more accurate. That's clear and loud. If it's modeling noise because they can't measure, then yes, but you need to add caveats and a range of values to the model noise results. And if you're making decisions based on model noise, you better validate the results against the actual noise measurements. In terms of reports, I've already mentioned quarterly is good enough. Trends are very important, and content relevant to each community is critical. So that's going to separate typically arrivals versus departures, not always, because sometimes depending on weather condition, flows revert. But you also need to ask the airport to separate daytime versus nighttime, provide data usage on specific procedures, the actual characteristics versus what was expected, how do they comply with what was published. And then the noise impacts, and I'll say here, a noisy plane for any community member is a plane that is louder than their background noise at that time. So my suggestion is N above in 5 dB increments above the background noise that can be reported. AICA can give you that. Then the reports need to extract the insights from all these tables and charts. And then of course, root cause analysis on specific issues. And for the data access, if the airport could provide, a download capability in Excel or CVS file, great, or make the data available upon request. And really, every situation will be different. Some airports may be already there on multiple items, some may not, and some are simple to implement. Nobody is going to complain about reporting quarterly instead of monthly, but doing root cause analysis requires more time and more resources. So you have to have that discussion. And really, the question is, again, is the content you're getting today, is it relevant? Is it informative and is it actionable? And the acid test is, ask yourself, is anybody doing anything with what is published today in the reports? Thank you.
Great, we'll begin the Q&A. Why don't we start out with Bill and Marie-Jo. Can N above be modeled or only measured?
I can answer that one. Both is the answer to that. You can
Both.
measure it at a particular point and you can model it to produce a distributed contour-like presentation like you've seen.
Okay, Greg, are there reports on low frequency noise behind runways, taxiways, and rev up as the aircraft departs? What actually capture noise experience of a taxiing and departing plane?
Are you talking specifically about Philadelphia or just in general?
I think it's a general question. I don't think it's just one airport.
I mean, there've been, studies on low frequency noise, but it's, not something that I have a lot of experience with as far as, having looked at that. When I was at Portland, we did do a study on reverse thrust noise during landing. And, how that propagated and how far that could be heard in the community and how that was transmitted. But as far as just, operating ground operations at the airport, no, I don't have any familiarity with that.
Marie-Jo, what distance from the airport should be included in reports and information sharing?
I would say for arrivals, probably 30 miles. For departures, probably 10 to 15.
Okay, Bill, for a NEAM, in order to validate, measure a contaminated noise event, would you require the building of a library or of aircraft sound for a baseline?
Well, effectively we do that. I mean, that sounds like essentially what a noise model is. I won't go into detail about exactly how it's done, but it's based on a lot of collected data that's then fed into the system.
Marie-Jo, who should prepare the quarterly reports for communities, the FAA, the airport, or someone else, and who should fund this?
I think I always believe that the FAA, because they design the routes and so on, should have a stake in the story. So they should be funding some of the reports. The report should be designed in collaboration with the airports and communities. And the airports, we are all paying, we're contributing as taxpayers to the FAA, and we're all paying air passenger fees and so on. So the airport and the FAA should pay for that.
Bill, does the NEAMS consider aircraft type, and how valid would the comparison of NEAMS reporting to historical traditional noise data reporting?
So it definitely does take into account aircraft type. What was the second part of that question?
Oops. All right, got a battery message. And how valid would the comparisons of NEAMS reporting to historical traditional noise data reporting?
So we've done checks on obviously the performance against that classic detection. Obviously, you've got to take into effect that classic detection may or may not detect the same aircraft. So you're trying to detect more aircraft, you'd expect the levels, the resultant levels to come back to be different. But there's been a lot of analysis done on it to validate the results and show that it's doing the right thing.
Greg, what is the legal obligation of an airport to provide data?
That's a good question. I mean, I can only speak in cases that I'm familiar with. I mean, in a lot of cases, the local cities or communities can drive that requirement. I don't know that there's any specific requirements. Philadelphia traditionally hasn't shared data publicly. It's something that when I was a noise manager there and now that I'm consulting with them, that we're trying to encourage them to do. I think there's kind of this belief that, well, if we share all this noise data, then we're going to create controversy and that's going to drive complaints. And I've tried to explain to them that if you don't share information, there's no trust there and people are going to eventually at some point, that problem is going to exist regardless. So it's best to be transparent and to share as much data as you can. That's my belief anyway, and that's what we've tried to guide them in that decision making. But again, a lot of that comes from the executive level and what they're comfortable with, and whether they think that noise abatement and community outreach and engagement is important. And if they don't, then it's hard to sell that.
I'm going to ask a question that all three of you can cover, but I think you should give some leeway how you want to answer this question. The question says, how does NOMS account for unequal community participation as in complaints? So that's a very layered question. There's a NOMS piece to it. And then there's just a question about complaints and their role and the weighting of them, not weighting of them, et cetera.
I'll start. Noise complaints are just an indicator of where a problem exists. There's plenty, so that's good. It shouldn't be a surprise. People know where the noise complaints are. You should not be making decisions because it's not a popular contest or because so many more people complain there and there, therefore we should fix the noise there. Because some people will not complain because they're too busy, can't do it, whatever. So the technology, either through measuring or noise monitoring, noise modeling, you can then really look into the impacts and then go to what's happening, what the root cause, et cetera.
I would say that I think that airports in general sometimes don't do the best job of make themselves accessible. And I mean that from not just a standpoint of can we contact you, but are we putting things out in multiple languages to reach people who are not English speakers? Are we making an effort to understand that complaints have a large component is socioeconomic. So I'll give you an example. When I worked in Portland, we went to some community meetings with some communities south of the airport, which were disadvantaged and poorer. And, we listened to a whole variety of reporting from the police and everybody else about all the issues that were going on. And I went and I talked to somebody and I said, so, we don't get a lot of complaints from you about noise. And I said, we have so many other issues that are so much more important, like crime and all these other issues that's just not at the top of our list. It doesn't mean that they're not annoyed. It just means that in the spectrum of things that are concerning to those communities, noise is not at the top of the list.
I think complaint numbers are a good example of data and not necessarily information. You can report complaint numbers and you can report that complaint numbers have increased tenfold, but that might be a tenfold increase in complaints, or it might be one new person has complained 1,000 times. So there's a stark difference in that underlying information. So it's important that it's presented and reported in the right way. And people are starting to look at, the number of contacts, the number of different complainers, the number of new complainers. These are other ways of looking at that data to withdraw the information out of it.
Okay, I think I'm going to end it at that at the high level. There's some technical questions that you might want to cover later, but I'm just gonna. All right, well, thank you, panelists. Thank you, audience.